All right, everyone. Sorry the last video cut off abruptly, but as I was going through the solution to this problem, we ended up running into some issues with the smartboard, and I figured would have been better to cut the other video in half and then just start this one, kind of split them up a bit. But anyway, so we're just going to go through and find the general solution of this problem. Remember, the general solution, we don't have any initial conditions. So go ahead, try to use a method of separation of variables to solve this differential equation. All right, so if you give this one a try, what we should have ended up with if we separate the x's and y's, we'll get square root of y dy is equal to 1 over 2 square root of x dx. And we can integrate both sides. Now, before I do that, realize that this too, it could have gone over to the other side and we could have had 2 square root of y if we wanted to. Constants don't really matter. Those can be on whatever side they want to be. It's just that you got to make sure all the x variables are on the one side and all the y variables are on the other. All right, so if we go through and solve this integral right here, we'll get 2/3 y to the 3/2. Remember, we don't worry about the c on this side, equals, not plus. I was talking about c, so I was thinking plus. So this will be equal to square root of x plus c. And then if we go ahead and solve, we'll get y is equal to 3 square root of x over 2 plus c raised to the 2/3. Now, some people might be noticing this c that I have down in here is actually not the same as that first c because we had to do things at both sides of the equation. But remember what I said. If we take some kind of c raised to a power, if we multiply a constant by another constant, if we add a constant together, if we subtract them, if we divide them, we just get another constant that comes out of the end. So why come up with all these different labels? Just call it c the entire time, because that's what it is. It's just a constant. All right, and there we go. This is the general solution. So we've answered this problem right here. And again, if we take the derivative of this, we'll just end up with what we got in the initial differential equation. Now, you guys saw me do this on the last video, so I'm just going to take it that you trust me now that this stuff actually does work, and we won't actually have to burn video time going over doing that. All right, so I had one more problem to do as an example. Now this one says find the particular solution, so you're looking for an exact solution, and this one is going to require you to kind of break out some of the properties of exponential and logarithms in order to do this particular problem. So try to solve this one, separate the variables. All right, so if you tried this one, hopefully you realize that we can rewrite this as dy over dx is equal to e to the x divided by e to the y. Remember that property of exponential functions? We can do that. So if we go through and keep going from here, we'll end up getting that e to the y dy is equal to e to the x dx. So integrating both sides of this is an absolute dream. We just get e to the y is equal to e to the x plus c. Or if we want to find our general solution, how do we get that y out of the exponential function? Well, we take the natural logarithm of both sides. So we get, y is equal to natural logarithm of e to the x plus c. And again, this is our general solution. But we want to find the particular solution. So let's go up here and apply our boundary condition. We have y of 0 is equal to 1. So that means that 1 is equal to the natural log of e to the 0 plus c. Or what's e to the 0? Anything to the 0 with the exception of infinity. That's just 1. So we get 1 is equal to natural log of 1 plus c. Now, again, practicing the properties of natural logarithms, how do we get to mess with that c inside the natural logarithm? Well, we exponentiate both sides of the equation. So in this case, we would get e to the 1, which is just e, is equal to 1 plus c. Or this gives us that c is equal to e minus, why did that minus sign get drawn up there? It's equal to e minus 1. So if we want to write our exact solution, we would say y is the natural logarithm of e to the x plus e minus 1. And there we go. That is our exact solution, and that is a solution to the differential equation. So hope you like these 2 videos. In class tomorrow, we'll be doing some more examples of this stuff, so come ready with questions.